Today my guest is Michael Lanzetta. Michael, how are you?
I'm good. How are you doing?
I'm doing great. Tell me, what do you do?
I work for a team called the Partner Catalyst team, and we work with startups or with labs inside large enterprise organizations to do kind of weird and wild projects that don't quite map to Microsoft technologies but are close. Particularly looking for things that we can run on Azure or that they can't necessarily do themselves.
Give me an example of something that's both weird and wild.
So we tried to build a deep learning solution to recognize fabrics, both the type of fabric and the color, for a company that was doing smart washing machines.
Oh, that's interesting. What do you mean we say deep learning?
So it's a particular type of technology that is an offshoot of machine learning, and it's really one of the more promising areas of machine learning right now. And the idea is that you take something which basically the machine learning community kind of abandoned a while ago, these neural nets, and you kind of go inception with it and you make it deeper. And so typical neural nets, basically you have your inputs, you have what they call the hidden layer, which is just a single layer of basically mapping the inputs to some sort of function, and then the outputs. And so the inputs might be a set of pixels for a given image, and the outputs would be, is that image 0 through 9, you know, which number is the image. So deep learning kind of takes that and goes deeper with it, and the idea is that instead of having a single hidden layer, you could have, 3, 5, 10, dozens. And what they've found is that doing that, you can start mapping to kind of higher level features and doing more interesting things with it.
And this uses neural nets, which we got away from and we're getting back to?
Yeah, we got away from them because they weren't as, when they were small like that, they weren't very promising as far as their ability to do these sort of classification tasks. And there were other methods that were more promising. So there are other methods in the machine learning toolkit that were more promising. And then basically, as time went on, two things happened to kind of bring them back in the limelight. One is we had a lot more data. So we now had these big data sets for people like Facebook and Google and Microsoft. And then we had a lot more compute power. Everybody had these, huge GPUs that were sitting on their boxes. If you want to run The Witcher 3 and you're not actually playing it right now, you can use that GPU to do interesting things. And it's very good at doing math, because that's what games are, is basically math. And so you could take that and you could solve these deeper neural nets and do interesting things with them.
Interesting. So we threw more hardware at it, and then it became practical again.
It became this sort of practical application of it.
All right. And what are you doing with it? What's your team working on? Or what
so we actually use deep learning to solve particular problems. One is this this idea of recognizing fabrics. Another is looking at academic papers and things like that, and trying to figure out what the relations are between different microRNAs and genes and expressions and things like that. And that there's different types of neural networks, and they're suited for different sorts of tasks. And so we are using deep learning toolkits to kind of solve those problems. So for an image classification task, there's a type of deep learning network called the convolutional neural net. And the idea behind that is the neurons that make up the neural net at some of the layers are what are called convolutional layers, and they basically take small subsections of the image and do interesting things with it. Just basically turn it into simple matrix math and then spit out a single number. And the idea behind that is they'll learn just through the application of these large labeled data sets and the learning process. They'll learn actual features. So this top level one will learn like, hey, I'm an edge detector. I detect edges that look like that. And then the next one over will be like, oh, I detect edges that look like that. And then by the time you go through this process a few more times and wind up at, say, the third or fourth convolutional layer, you'll have these neurons down here that are like, I detect cats, or I detect dogs.
Okay, so first they have to figure out where the edges of an image are, so they can know what part of the picture is the image. And then later on they could say, okay, what is this image? Is it a cat? Is it a dog? Is it
exactly. And they just keep basically detecting these kind of
a Microsoft engineer.
Exactly. So they detect like these kind of like coarser grained features. They go from simple edges to this is a head to this is a cat.
Interesting. And those are we're talking about a lot of data here. So something like the cloud really empowers this, because you can throw a bunch of machines at it all at once.
Yeah, and that's really where these things shine. Is in these large data sets. So if you upload all your photos to OneDrive, that's the kind of technology that drives that. Is we can figure out what things are in there because of that. Facebook has the same sort of thing with their photos.
And what's Microsoft doing with it? So we were developing these, I'll call them algorithms or neural nets to.
We have a very strong deep learning team at Microsoft, and there's actually an annual competition called ImageNet, the ImageNet Challenge, that we won this past year.
All right.
And we...
Yay, us.
Exactly. We have a very strong team doing very interesting work in that area. And if you look at kind of the way that ImageNet has been progressing with deep learning, 1 year, the first time kind of deep learning solution won, there were 3 layers.
Okay.
And then the next time it won, there were 8 layers. And then this last year, we had 152 layers or something like that.
Oh, wow.
So we really have kind of evolved the field. Yeah. And are trying to solve these problems, because once it gets to that number of layers, you wind up with all sorts of weird problems that, frankly, I don't even understand.
Okay. So we're winning contests with it, which is awesome. Yeah. But are we productizing it? Are we selling it? Are we giving it away? Or what?
So we actually, Google kind of started publicizing deep learning when they came out with TensorFlow. It had been kind of around the machine learning community, had been very interested in it, but Google kind of brought that to the broader fore with the publication of TensorFlow as this open source toolkit. What many people didn't know is we actually had published CNTK, which is our kind of version of TensorFlow almost. It's our computational network toolkit for building these kind of deep learning solutions.
And we've open sourced that?
And we open sourced that on Codeplex before they did TensorFlow, and we've now moved that over to GitHub.
Okay.
And so it's out there.
Now people know it's there.
Yeah, it's ready to go.
Sorry,
people
Codeplex.
can use it. Yeah, exactly. And so it is a great solution for doing these kind of deep learning problems, and it takes a different tack than TensorFlow does.
Okay.
So TensorFlow is built as kind of this Python add-on module. So you use it within Python, you build most of your code in Python, and then build these TensorFlow models around that. And CNTK, there is a Python binding coming, but the idea is that it runs on Windows or Linux or Mac, I guess, and it you specify these configuration files in a particular type of language that says, this is how I want my network to look. And so the configuration files are pretty easy to read, and they allow you to tune all the different parts of the network.
All right.
And you can actually write fairly simple macros in these languages to introduce 2 new types of networks. And you can write fairly simple code to introduce new types of neurons. So it allows people playing around with the networks to do interesting things, and it also allows researchers to introduce new types of neurons pretty fast. And then when you train these models, you can actually deploy them, and you can use C# code to use these trained models. So you can pretty easily deploy them out to Azure as services, or use them on your local box, whatever you need to do. Once you've trained the model, it's pretty easy to deploy it.
So the idea would be somebody would clone this repository, build some sort of model based on their own data, and then build on top of that. Now they've got some predictive analysis. They would publish some service that would be able to predict future data from that, and maybe build something else on top of that.
Exactly.
That's pretty amazing. That's and we're doing it ourselves here, right? I mean, some Microsoft teams are doing pretty much the same thing, right? They're taking that same algorithm and making Microsoft products better.
Oh, very much so, yeah.
Like what?
So obviously Cortana is built on this kind of deep learning technology.
Okay, I'm not sure how obvious that is, but it's,
sorry. Yeah, so Cortana,
it totally makes sense to me.
When you speak to Cortana, it's basically analyzing that speech using deep learning techniques. The Skype real-time translation is all using deep learning techniques.
Really? Okay. Does that mean they get better as time goes on?
Yeah, that's the idea, is basically as we get more data, we can retrain these things, and we can actually use the existing models as inputs to the new training. So we can make them better over time, and we can basically iterate on them very fast.
Wow, very cool. And I think you mentioned the Project Oxford before off camera, that they're using.
Yeah, Project Oxford is using them extensively. So there are techniques for doing this kind of text analysis. I don't know if you've seen the Lewis project within Project Oxford.
Which one is that?
It's for basically understanding text. You can train models on that.
Okay.
I believe that's using deep learning underneath. I haven't talked to their team, but that seems to be the baseline for a lot of these things. And then, like I said, Cortana Analytics is all part of that, and so the deep learning toolkits are being used more and more in these areas. Bing is using deep learning for a lot of things.
Very cool. Where would people go to learn more?
So CNTK is on GitHub. So if you just go to GitHub and you look for CNTK in the search box, you'll find it.
We'll put a link to that.
Yeah, and that's it's got a wiki on there in the GitHub where it walks you through a few examples, and then it's got 2 publications out there. One is a simple tutorial, and one is actually kind of the full book of CNTK that walks you through, how you would go about contributing your own models and contributing your own neurons.
Do you have an online presence?
Yeah, I'm Mike Lanzetta MikeLanzetta.com is my blog, and I'm Noodle Frenzy just about everywhere. So.
Noodle Frenzy.
Yeah.
What's that?
It's comes from my gamer tag back in the old days of Halo.
Okay, we'll have you back here. We'll do a whole show just on why you're called Noodle Frenzy.
Great.
Thank you so much, Michael.
Thank you so much.
And thank you so much for joining us on Technology and Friends.
So one of my favorite things to do is to use deep learning technology to play tricks on my friends.